Okay, so previously we had brought non-extensible applies to private to the committee, and we rapidly got from no stage at all to stage 2.7, which all of us really appreciate, having been able to do that. Today I was going to ask for stage 3, but reality interfered. So this is just a 2.7 status update to bring up some issues that I hope we can discuss so that in a future meeting I can bring this back and ask for stage 3. So to recap, the two green highlighted lines are the entirety of the proposal itself, which is to ensure that if an object is non-extensible, then in the same way that you cannot add public properties to a non-extensible object, we are here proposing that you cannot add private fields to a non-extensible object. And to recap the motivation, here's a little abstraction called tagger that uses return override in order to add a little private tag to any arbitrary object. The Shu's motivation Shu and I are co-sponsors of this. Shu's motivation was primarily had to do with wanting high-speed implementations of structs, which require with optimizations that depended on structs having fixed shape. And within the current spec, it's not possible to implement structs with fixed shape because there's nothing to prevent one from using the tagger abstraction to add a tag to a struct instance that would, in realistic high-speed implementations, cause its internal shape to change. So with this proposal, because struct instances are born sealed, the attempt to add a private field to it, which happens right over here, would throw a type error, and you get the same safety that you would have gotten if you were adding a public property. And by the way, I should say, I'm still hopeful that structs, not shared structs, but just normal structs, normal unshared structs, I'm very hopeful that that does go forward. So I do share this motivation. But for me, this is the primary motivation. It's the exact same tagger abstraction. We, Agoric, implement a virtual object memory system in JavaScript where there are a particular class of objects, we'll call them virtual objects, where you can, for example, have a virtual collection that is larger than your JavaScript heap, where the virtual collection is keyed by virtual objects and it spills out to disk. But when the virtual objects are referenced, they get, so to speak, paged back into disk, creating a representative, which is a JavaScript object. So weakness aside, a representative, each time it gets faulted back in, it's represented by a different JavaScript object. But because no two representatives for the same virtual object are in the heap at the same time, aside from weakness, it is undetectable that it has a different JavaScript object identity. To deal with weakness, what we do is we replace the global weak map and weak set constructor, and we could also replace the global weak ref and finalization registry. And by replacing them with things that are aware of our virtual object system, we're able to ensure that that the change of identity of the representative at the JavaScript level is not observable. The hole in that story is demonstrated using the exact same tagger thing, and that's because return override with the current behavior means that there's a primitive weak map effectively reachable by syntax in the language, which is the only way to account for private fields with return override. So over here, if you tag representative 1 with A and you get it while it's still in memory, when you're still holding on to representative 1, you get back the A. That's fine so far, but then if representative 1 is garbage collected and the virtual object system is trying to transparently revive it, creating new object representative 2, then because it has a different JavaScript object identity, this is the one place where that difference of identity remains observable, which breaks the virtual object memory illusion. So with this proposal, and given that our representatives, one of the constraints we already have in our virtual object system for other reasons is that the representatives are always frozen, then the tagger immediately fails to tag a representative, closing the one hole that we could not fix in the virtual object memory illusion. Okay, recap plus plus. Last time we brought this to the committee, we were showing this graph as of April 1st. So I redid this slide going to the current stats on the Google web page where Google is accumulating these stats. And as we see for this graphic, it seems to go down, which isn't necessarily good news, but at least it's not bad news. The reason I say it's not necessarily good news because it's probably within the error tolerance. But obviously, the linear best fit continuing to go up is noise we can ignore with regard to this piece of statistics. The other piece of statistics on the Google website is more alarming, and I would like to work with somebody at Google to understand what this means. But it's showing an increase in June over where we were in April and May, and then a decrease from June to July, but still a mobile increase in July over May or April. But all of these numbers are still tiny, tiny small, and I don't know of anybody who has reported any source of these anomalies aside from the one that Shu reported as of our last meeting. So Shu reported 2 anomalies, one of which was that there was exactly this pattern being seen on one website, and it was mysterious to us at the time why anybody would write code like that. And then on the issue number 1 thread on this proposal, James Nader pointed out that the anomaly we were seeing was exactly that would be generated from Babel. So now I'm taking that same observation, but throwing at it a slightly more challenging test case, which is the code on the left, for which Babel today generates the code on the right. So this led to a wrong, and the code on the right is code that does break if, once our proposal becomes standard. Our proposal would break this code on the right, or let me call it the code in the middle, because after a lot of back and forth, especially with thanks to Niccolo and Richard Gibson, as of this morning, just shortly before my talk, Niccolo proposed the code on the right as an alternate translation that seems to be fully spec compliant with the current spec and would remain spec compliant following this PR becoming part of the language. So thanks again to Niccolo and Richard for that. And that is it. So I'll now stop recording and take questions.